our last paper in discussion by Toni and Emilia Koch from Stuttgart.
Thank you very much for inviting us to this conference. For Julia and me, it's the first time. In Estonia, it's an inspiring country, as since Johann Gottfried Herder approaches to popular folk and folkloristic genres were also born in view of Estonian musical and literary tradition. Julia and me would like to talk about the Boy's Magic Horn, which is a collection of poems. I will start with a brief introduction to our research context and the main characteristics of this collection. In the second part, Julia will demonstrate and comment some recent sonic experiments. Our presentation comes out of the research project Textklang, which uses a mixed methods approach to investigating the relation between written lyric poetry and its sonic realization. Our group includes scholars from literary studies, digital humanities, computational linguistics, laboratory phonology, and speech technology. We are based at the University of Stuttgart, Institute for Natural Language Processing, and Institute of Literary Studies. And we are also based at the German Literary Archive in Marbach, Deutsches Literaturarchiv Marbach. Textklang is funded by the German Federal Ministry of Education and Research. In Textklang, we aim to investigate the interrelation between written lyric poetry and its sonic realization in recitation and musical performance. We aim to analyze prosody in written poetry and sonic realization. In this, we would like to concentrate on interjections and enjambments, to develop text-to-speech synthesis for perception studies on prosody, and to collect metadata to visualize intertextuality and intermediality. In our presentation, we will concentrate on plotting data and metadata in the Keshiv app and on plotting sound through text-to-speech synthesis. This is Julia's part. The Textklang corpus is centered on lyric poetry from the period of Romanticism. It's fed from holdings of the German Literature Archive, from the library, and the archive are available around 4,250 printed texts, 2,400 manuscripts, and 1,400 musical scores. From the DLR audio collection are available 2,700 recordings. Furthermore, the corpus is increased by own production. We are going to record 700 poems from the Boy's Magic Horn and 180 children's and household tales by the Grimm brothers. To discuss the project's multi-perspective approach, Julia and me would like to further concentrate on the collection within the corpus entitled The Boy's Magic Horn, Old German Songs, edited in 3 volumes by Achim von Arnim and Clemens Brentano in 1806 and 1808. The collection, written in German, includes about 700 lyric poems, which are versified and rhymed, as well as a few texts in prose. Prominent genres are songs, ballads, children's songs, prayers, and short plays. Subjects and themes of the Boy's Magic Horn are everyday's life, Christian and Catholic religion and faith, history, myth, nature, societal and political experiences, especially rural environments. The Boy's Magic Horn also includes time-specific, misogynistic and anti-Jewish stereotypes. It is one of the main characteristics of the collection that it is deeply rooted in late medieval and early modern literary tradition. The Boy's Magic Horn is considered to be one of the most influential collections of lyrics in German literature because of its vivid reception both in low folkloristic cultures and in high cultures, especially musical settings, for instance by Gustav Mahler, Johannes Brahms, Friedrich Silcher, Robert Schumann, or Bob Dylan. The data we produce and we deal with are text files and audio files. The text files are extracted from Deutsches Textarchiv, which is a collection of digitized first printings of German literature, corrected according to the scholarly edition by Heinz Röllecke and modified after the recordings. The audio files are recorded at the Phonetic Lab of the University of Stuttgart. The speaker is Toni Bernhart, with me. These are some photographs about the work and the recordings, some situation. This is our recording team, Wolfgang Bokurek, the head of the Phonetic Lab, and me with our student assistants, Kerstin Koschemann and Faria Hack. The metadata we collect are the titles of the singular poems, the number of tokens per text, genres of the texts, the level of expressivity or rhythmicality, the names of the authors of the sources and pretexts with an obvious intertextual relation to the singular poems, and the year of publication of these sources. Keshiv to visualize data and metadata. Keshiv is a web-based visualization and analytics tool which explores datasets quickly. To prepare data for Keshiv, data are collected into a JSON file and imported to the tool. Try out. To give you an idea of how Keshiv works, I will show you a short video, and I would like to ask the conference organizers to send this link also through the chat and via email to all participants. This is a preliminary publication of the data and metadata of the third volume of the Boy's Magic Horn. We have prepared this link. It's not published, but we opened it for you in this conference. The link will be open for 1 or 2 weeks, then we will close it and reopen it when the metadata publication is finished in maybe in 1 year or so. Well, I would like to give you a short idea what you will see when you enter this link. The Keshiv starts in order of the printed books. You can filter by authors or sources, you can filter by genres, you can exclude or lock several features and combine them. You can read the text and you can hear the recordings and so on. Try out. find out what we can do with this tool and what kind of metadata we are combining. And now I hand over to Julia.
Yes, thank you, Toni. In the remaining part of our talk, I want to present you an experiment about synthesizing poetry with means of speech synthesis. And what we did is we trained a text-to-speech synthesis, or TTS model, on our recordings of the Boy's magic horn. And the Boy's magic horn is actually a really interesting corpus as training data for speech synthesis because of its linguistic variety and wealth in topics and genres. And of course, we have the advantage that it's our own recordings, so we don't have to care about copyright. And what we're going to look at is how does the TTS model perform poetry, and is it really enough to simply train on poetic data? As I assume not everyone here is familiar with TTS, I just want to give a short introduction about how it works. So what we want to achieve is we want to go from text to a representation of speech, which we can actually listen to. We start with text, like heute ist ein schöner Tag, which means today is a beautiful day. But if you don't know German language, then you still don't know how to pronounce this. For example, we have the combination of the EU, which is pronounced as oi, or the SCH, which corresponds to the sound in German. And in order to simplify this, we have a tool called Phonemizer, which translates it into phonetic transcriptions, which is the thing you can also find in dictionaries, for example. So here, each character in the sequence corresponds to exactly one sound. But still, this is kind of textual representation. There's still a lot of information missing if you want to listen to this. This is the really hard part, because there's an infinite number of possibilities to say one and the same sentence. So the speaker identity plays a role. Sentence sounds different when I say it than when Toni says it. Speakers might have accents. There is, of course, also the prosody, which strongly correlates with emotion. I sound different when I'm angry than when I'm really happy. And there's also style properties, like reading a newspaper usually is different than reading poetry. And all of this missing information has to be learned from data. And usually this requires a huge amount of audio segments and the corresponding text. And there are some restrictions on how this data should look like. For example, the audio segment should be rather short, like 5 to 15 seconds long. From this, we can generate a spectrogram, which is one representation of speech. We see on the x-axis is the time, and on the y-axis is the frequencies, and the color indicates the amplitude of different frequencies. Still, we cannot listen to this, so we have a final step which translates this into a waveform which we can actually listen to. The challenges we face, especially when dealing with poetry, or in particular with the Boy's magic horn, is that we have highly non-standard text. There are a lot of uncommon words, like old word forms, which nobody would use nowadays. We have lots of proper names, neologisms, phenomena like onomatopoeia, and so on. Then there's inconsistent and old spellings, which will cause many errors made by the phonemizer. And there's also problems with shape and formatting of the text, so we have stanzas with very different lengths. There are sometimes prosaic explanations mixed within, so it's not clear how to split the data into shorter parts. There are also some things like random line breaks, which is just errors in formatting, but of course there are also enchantments which are intentional and they should be in the text. And also on the speech side, we have very unusual phenomena like unusual stress due to the meter of the poems, and of course the creative freedom in realization of the speaker, like variations in speaking rate and expressiveness and so on. The experiment I want to show you is we compare a TTS model trained on prosaic data versus our TTS model trained on poetry. All models are implemented with our IMS speech synthesis tool in Toucan. If you're interested, you can take a look at the QR code. We have some more demos and interesting stuff there. The training procedure is as follows. We do a multilingual pre-training on many hours on 14 different languages. We find this useful in order to build a robust system which can deal with prosodic variations from the poetry. And then we have our baseline system, which we train on German prosodic data, which we compare our poetry model against. And the poetry model is additionally fine-tuned for a little bit of time on the Boy's magic horn. In order to do so, we first have to automatically pre-process the poems, and we start with 211 poems, which we have available. And we cut the text and the audio into short chunks, because, as I mentioned, the audio segments should be rather short, so we cannot use a whole poem at once. And we do this heuristically to split it up into chunks of 2 verses each. Then we automatically remove problematic samples, which cause the training to crash. And finally, we end up with 2,348 text audio pairs. To get an impression how our models perform, we just take a look at this. First, we listen to the human.
Maria, wo bist du zur Stube gewesen? Maria, mein einziges Kind.
Compares to the baseline.
Maria, wo bist du zur Stube gewesen? Maria, mein einziges Kind.
And our poetry.
Maria, wo bist du zur Stube gewesen? Maria, mein einziges Kind.
And we notice 2 things here. First, that the poetry model sounds a bit muffled, which is due to still some errors in the training data. But on the other hand, we see that the baseline model, which is not trained on poetry, has really flat prosody, and the poetry model sounds a bit more vivid and makes longer pauses. And to verify our impression in experiments, we compare our models on 7 unseen poems. Unseen in this case means they were not present in the training data for the models. We look at speaking rate, which we calculate as the average number of phones which are produced per second. And we see here that the human has rather low speaking rate compared to the baseline, which produces much more phones per second. And we see that the poetry model seems to adapt to the human in terms of making speaking slower than the baseline. So it actually has learned speaking rate from the data. And we also look at the duration of pauses. We exclude silences at the beginning and the end. And also we see here that the human makes rather long pauses compared to the baseline, which makes really, really short pauses. The poetry model still makes short pauses, but a bit longer than the baseline, so this is good because it also seems to have improved compared to the baseline. Finally, I want to show you some examples. Let's first listen to the first line of the title poem, The Magic Horn. Also, first the human, then the baseline, and then the poetry model. But das war's schon.
Ein Knab auf schnellem Ross sprengt in der Kaiserin Schloss.
And here we already hear that automatic segmentation was not perfect because we had this noise at the end. So that's a huge problem we're dealing with.
Ein Knab auf schnellem Ross sprengt auf der Kaiserin Schloss.
Ein Knabe auf schnellem Ross sprengt auf der Kaiserin Schloss.
And here we also hear that the speech quality of the baseline is clearer, but the poetry model has better prosody. And we also see an instance of a phonemizer error because we had a short vowel in the horse, which translates to horse in the human speech, which is correct, but the TTS models produced a long vowel, which should not be the case. And this is caused by the old spelling of the word. Then the next example is quite interesting because the poem has a structure like in each stanza one component is added and the rest is repeated and stays the same. First there's the chicken, then there's the duck and the chicken, then there's the goat and the duck and the chicken, then there's the pig, the goat and the duck and the chicken, and so on. And the human speaker realizes this with variations in speed. So first we listen to very short, at the beginning of the poem, where the duck is first introduced.
Ente Quentlein heißt mein Entlein. Büberlein heißt mein armes Hühnelein.
Ente Quentlein heißt mein Entlein, Büberlein heißt mein armes Hühnelein.
Ente Quentlein heißt mein Entlein. Büberlein heißt mein armes Hühnelein.
compared to later in the poem where many other animals have tried to party.
Entequentlein heißt mein Entlein, Weberlein heißt mein Hühnelein.
Entequintlein heißt mein Entlein, Überlein heißt mein Hühnelein.
Entequentlein heißt mein Entlein, Überlein heißt mein Hühnelein.
And yeah, we see the human has much more possibilities to express these differences, but the TTS models just have no context information available, so it sounds the same at the beginning of the poem and later. And finally, we look at an example of onomatopoeia, so we have the sound of a flute and the sound of a drum.
Dill, 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 so macht meine Flut, rum, rum, bidi, bum, so macht meine Drum.
And we see that in the human speech it almost sounds like music.
Dill, 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 so macht meine Flöte rum, rum, wie die Bum, so macht meine Drum.
Well, this is just read out.
Dill, 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 so macht meine Flut, rum, rum, bidi, bum, so macht meine Drum.
In summary, we can say that the Boy's Magic Hall is a canonical and very diverse collection of romantic poetry, and this makes it paradigmatic for many research questions. The synopsis of text and audio files and metadata allow us to study prosodic patterns in text and sonic realization. TTS and the Magic Horn in general has the problem of dealing with automatic preprocessing, which is difficult both on text and audio side. And errors, mistakes in this preprocessing have bad impact on TTS speech quality. Nevertheless, we see that the TTS model captured some stylistic properties, like speech rate and pauses from training on this project data. However, there are still lots of phenomena which cannot be easily captured in the TTS as it is now. Thanks for your attention.
Thank you for this very great talk. Do we have questions in the room?
Thank you very much. An amazing talk. I was wondering, like, very technical question actually. What do you think about using the TTS, text-to-speech generation, to measure the exactness of rhymes? So you use like the sonic profile, basically the wave profile, to address the issues of how similar phonetically rhyming pairs are, because there could be a difference in them. I mean, there's obviously, this is like a brute force way to do that, because you can use it, like, model it like properly from a phonological perspective. I just think, what do you think about that?
Yeah, it might be not so exact, but it was just a first experiment to measure some differences in our TTS models.
No, yeah, I have no questions to TTS models. They're great. Just asking about your vision on the perspectives of using that for an application for measuring like similarity, sound similarity in rhymes. Oh.
I'm not sure I understand the question.
Yeah, okay.
Maybe rephrase it.
Don't mind me.
What kind of information would it bring on the top of the phonetic transcription?
Yeah.
Okay, sorry.
Microphone.
Can you again, please? Yes. I have more just a reaction to Artem's. My question is, using the TTS synthesis for rhyme similarity comparison, what kind of information would it bring on the top of the phonetic transcription generated in step 3 or something? So, what the actual sound would, what actual information would it bring on the top of that?
Well, it's probably not the discussion that we have right now.
But then, because, yeah, of course, the phonetic transcription there is, but again, using the phonetic transcription, I mean, you can basically you model the wavelength, right? So you basically model the sounding, how the rhyme could sound, and because the machine would render them like similar to each other, and so you don't need to get into the how how sound is produced in your apparatus, and then you can just measure the waves, like the similarity between the sequences. But sorry, this was a confusing question. My was just, yeah, let's speak. Let's have this conversation like around.
Yeah, so we can continue about that later. Are there any other questions here?
Yeah, it sounded for me that your model trained on poetry had a better prosody, so I was wondering whether there is a mathematical way to compare it to the prosody of the human by comparing spectrograms.
There are some measures like spectral distortion or F0 frame error, but these are a little bit hard to interpret. So because the spectrograms are quite different and they should match closely in order to make sense for this metrics. So we're still working on finding relevant metrics for this. And actually the keynote talk yesterday was very interesting for this part with the tool that automatically identifies genres. So we hope that we can get something out of this.
Yeah, Niels has a quick question.
Sorry if you told it in the intervention, but I was wondering the level of expressivity. You were talking about it in the beginning. Is this something you measure, and how do you do that?
Yeah, this is a round point, the level of expressivity. Yeah, yesterday we discussed about it. We are not sure what we hear, what we do, what we will do with this feature. First we called it level of rhythmicality. And we discovered there is some, it's a measure in 3 levels, 1, 2, 3, which we measure by the ears, by human impression. So it's a work in progress. So we started some weeks ago with this new feature. Could be a characteristic for recitation, but is it for the recitation or for the text? So, and what is written and what is expression? And what really do we hear? Yesterday we discussed about it. Could we find a way to technically define or to redefine this feature? So we took this feature, we continue to try out. Maybe we cancel it. Maybe, and this is a little bit to add to the first question and to the discussion before. The aim of the project is, it's from the literary studies and from computational linguistics and speech technology. So in literary studies, research on lyric texts is, has always been a little bit esoteric for the last century. So why not use empirical approaches and combine them with hermeneutic approaches? So what is written, what is rhyme? It's a lexical, a vocabulary always strongly related to musical experience and to a musical expertise. So there are a lot of points where we would like to go into a dialogue. What is rhythmicality? What is written? What do we hear? What can we measure? And how can we start an interrelation between these two approaches, between a technical, empirical, mathematical, technological approach, and between a hermeneutical approach into the context of the context. Yeah. So
Maybe to add to this, the idea behind this feature was to group some poems together because there is no such thing as one poetic style. And it's really difficult to train a TTS which reproduces poetic style if there's so much variety in it. So we wanted to use this fine-grained clustering to have more precise control on how the TTS should sound like. And that's the idea, and we just tried out how can we cluster the poems and find out what are the criteria for this.
And this was for us a very a moment of inspiration and of joy when we discovered that there are empirical features which probably make part of a poetical speech. So for our group it was an inspiring discovery when you taught us about this how these features you can measure to define or to start to define a poetic speech. So it was very interesting.
Okay, so yeah, that was very informative and inspiring. Any other questions around here? I see no questions on the chat. I sent a link on the chat. You asked us to send a link. I put on the chat there. I didn't have the email. It's the interface.
I prepared it in the table and asked you to send it.
Yeah,
maybe
it's there in the chat. Maybe we can send it later by email, perhaps.
it's in the conference table.
Yeah.
Please send it to via email. So you can try out. It's very fun. Also, Koch too.
So thanks a lot. Thank everybody for this wonderful session too. All speakers. So we can go to the final applause and stuff. And